Alright guys, welcome to another RMA Fire tutorial. And in this tutorial we're going to be talking about some viscous liquids. So let's have a look at my sequence render, which is what we're going to be talking about in this tutorial. So I am not sure where I saw this. Like a really long time ago I saw a tutorial on some viscous fluids. I'm pretty sure it was on real flow, and it was also, it had some strawberries and it had some chocolate poured on top. I'm not entirely sure exactly where I saw it, but I think it was really cool, and I was like, oh man, like it's on my head, I wanted to do it, I've never had a job that wants to do that kind of stuff, so let's make a tutorial about it, because I think there's some cool stuff to see, and I didn't want to do it with chocolate, so I thought, well, let's do like strawberries and cream or something like that, right? So how do we go about creating something like this in Houdini? So this is my scene. I have my cameras here. I'm gonna leave them for you guys. I'm gonna give you guys two project files, one class and one the actual one that I used. The one in the class, the resolution is gonna be much lower so that we can look at what we're building. And the same part of things here is where I am first organizing the geometry and then doing the simulation stuff. Let's have a look at, let me delete this because I didn't end up using this. I'm gonna send you guys this geometry that you can use. It's a strawberry that I found, I don't remember where. I had it in my material library forever. Of course, this is something that is non-commercial, guys, just to be, it's just for educational purposes, right? Sorry if you hear our weird noises. I've got my Rottweilers right beside me, hanging out. Alright, poly reduce so that we don't have so many polys. And here I am giving them a value of 1 so that I can kick out a mat. I like to do mats like this. So my fruits are equal to 1, which is a white value. Here's my fruit material. And here I am basically organizing the fruit so that they are in a composition that I thought was cool. So I kind of set them up like this. So the reason why I am scaling them up is because I personally, I don't really enjoy simulating small scale liquids. It is much more complicated. So this is not real scale. This is 10 times the scale of a strawberry. It's actually pretty large, but it gives me some really nice results. It's easier to control. So here we have my our collider, and this is our VDV that has a 0.02 out VDV collider so that we can use volume-based collisions. All right, and I have this right here to visualize the source animation. So these two nodes here are just visualization. All right, guys. So I have two more. I use them for visualization. So this is gonna give us our visualization of how the emitter is being emitted, and then this one, the animated, and then down here, this is the visualization of the end result. So for our emitter, I started off with a box. Then my box, I rotated it 45 degrees here and here, and scaled it down. And I created a flip source. And this flip source, I am connecting that inside here, our dotnet. I'll show you guys now view or what this means. You can see that I have a particle separation of 0.03 and I have it labeled to create particles. The transform basically just rotates it based on $F and translates it into, so it pushes it up in the Y and it's gonna constantly rotate. I'll show you guys. See, so it's about creating an interesting emitter. Like you could even create a mountain saw. Oops. Mountain here to kind of move your, you would need more subdivisions, but you guys can play around with the emitter that you have, because interesting emitters really make a big difference in the result of your simulations. So stuff like that really makes a very big difference on your emitter. This trail right here, alright, so this is just transforming it in the Y and creating my animation. If we come here into, for example, a camera like this, and just scrub through, you will see this is the animation that I had, and I'm merging it here so that I can see kind of what this animation is doing to the strawberry. So my emitter is kind of moving on top of them like this. So I am animating by hand. This is not procedural. I can definitely think of ways for us to make this procedural, like the animation procedural. Like we could create a null and animate the null so that it moves around, or we could use chop, like motion. I forgot the name. Actions. Motion effects. I'll use something like a noise here. What that will do is, if we were to put it here, do it here, motion effects, and do the noise or whatever you want to use. You can use this here to procedurally animate it and control it based on like less harmony or whatever. I mean, there's definitely options for you guys to play with making an animated procedural animation for this. But honestly, I really wanted something very specific. I wanted the animation to like specifically move the way that I had it. So sometimes it's okay to do like manually based keyframes. If you for whatever reason you're new to Houdini, doing those animated keyframes are very simple. You can just create a transform, hit Alt, and click whichever parameter you want to animate. Move this wherever you want, and you will create your animation like that. And in Houdini, let's show you split top and bottom. We come here into our animation, editor, hit H, and here's where you have your curves, so that you can animate using your curves and have more control over the animation. But this isn't that kind of tutorial. So once you have the source animated in the way that you want to create a trail and compute the velocity so that we know what is the velocity that we're going to import into the .NET. After this, we have the outsource, and we're going to create a .NET. That means .NET here. If you type .network, it will create the .NET. Let's have a look what I did inside of the .NET, because here's where the magic actually happens. We're going to create a first stop so that we don't get confused. Let's look at this in a simpler way. We'll just focus on this couple things here. Okay. The first stop of the bat, say for example, you're going to create a flip object. Okay. So you type flip object, oops, sorry guys. We come here and we do flip object. And the flip object is essentially where the initial data, you want to delete this path. And the particle separation, this is what I'm referencing outside. So when I told you guys that the voxel size here, I am referencing the particle separation from inside. So right now, I'll show you. I'm gonna set this to 0.1. Well, I'll set this to 0.1. And we'll come out here. And it should cheat it here. Let's see. Channel, flip source 2, particle separation. Flip source 2, particle separation. Okay, so it is changing it. I just have to multiply it by 2 here. So 0.1, see? But whatever I am doing inside, I'm multiplying it by 2 here. So it's 0.2 on the voxel size. So whatever, when we change this, is that automatically gonna update it outside. That's it, very simple. The guides, on the guides, you will see that if you go to particles, I have it labeled particles here so that we can visualize this as particles. And so I'm just gonna put this here. And what I am doing here is that I want to visualize it based on viscosity and a range between 1 and 500, meaning that it's going to change color based on a viscosity. So 500 being white and 1 being this color, or maybe it's the opposite. It's the opposite. See, it starts white and then it's going to start to get here as it gets closer to 500. I'm visualizing this based on speed. Let me see if I don't think I changed anything else here on my flip object. Yeah, so that's basically what I changed in the flip object. Then the flip source, this is where I am using the soft path. So you want to do volume source. And inside of our volume source, you will see that we're doing this soft path. What that means is that it's referencing this. So this is how we import this into the flip object. So we want to say flip, source flip, and it's going to automatically create this. So it looks the same as the one that I have here. See, that's basically all that I was doing here. Bringing in the information so that this here knows that these are the particles that we're going to simulate. And then if we go to particles, I change the time offset and scale to 0.1, and that's it. What the time offset scale is, if you hover over, it'll tell you what the parameter does. So offset any new particle by adding their scaled velocity multiplied by a random portion of the current time step. So it helps ensure the emitted stream of particles appears regular even at low simulation substeps. So you want to use that if you're not going to increase your substeps here. Because my substeps are super low, we can get away with doing that. I do recommend doing that because, as you can see, like, we're getting nice results with minimum substeps. So if we select the flip object, I'm changing the time scale to 0.6. Time scale, what it does is that it just slows down the whole simulation. So like you'll come in as 1. So what I'm doing is I want the simulation to feel like more slow-mo. The minimum substeps is pretty low, substeps to 3, but as default is even lower. See, that's it. Then the particle motion, I want to create an ID attribute on each of my particles so that I have an H attribute and an ID attribute. ID attribute is basically like a number for each of the particles, and the H particle just gives each of your particles an H. They're reseeding. This part is important, and I left it here for you guys with notes. I am using surface oversampling. So basically what the reseeding will do is if this is an object and you have a liquid that is coming down and it's like starts to break before it reaches the ground, this is very common when you try to do viscous simulations. If you crank up the surface oversampling, it's gonna fill that up with new particles. So when you mesh, you get those nice tendrils that are connected. And then I'm adding the age and the viscosity so that these new particles that are created inherit the age of the other ones and the viscosity as well. I left here surface oversampling. It's forcing more particles on those areas, and we are interpolating those attributes so that they inherit the age and the viscosity of the new particles we seeded. So that like the new particles keep the age and the viscosity from the other particles. Alright, and I left you guys one more note. This one I'll chat about in a second. I did add a little bit of separation, which literally separates the particles a little bit, and a little bit of vorticity, which, I mean, like, you don't need that. You really don't. But it just adds a little bit of cool, like, vortexy look to your particles. This splash per nil, volume limits. What this does is it's this box here. So if I change this, you'll see the number changes here. This is gonna change for any of your scenes. But if you're doing a small simulation, like you do want to keep it small because it optimizes and it makes things way faster. So viscosity, here's where you want to enable viscosity. Of course, you can come in here as well and enable it on the viscosity tab. I don't use it. I don't really use this one as much. Yeah, so there's people that come here and enable it and start to crank the viscosity up in here. In this case, we want to use it here because we are creating the viscosity as an attribute. So with the attribute, we can control many things, as you guys know. And we're going to use this attribute to control it with this bomb, to control the viscosity intensity based on the age. And then we added surface tension. What surface tension is, it just like forces the particles to stay closer together. This is a cool parameter you guys can play with because if you increase it, the particles are gonna force themselves to be closer together. This two I didn't touch. All right. Before we talk about these two things here, let's chat about the other stuff that is a little bit easier to digest. So the cookie collider, I named it cookie collider because it used to be a cookie, but in this case we're gonna change the name to fruits. The fruits here is where we are creating the collision for the fruits. So how does this work? We create a static object and we select the sub path to point to the out collider here. See, which is the fruits that we had created initially. So this is referencing that. And then right here, we choose what kind of collision object or like collision source, what kind of collision we want to create. So there's multiple different kinds of collisions. In our case, we're going to use a volume collision. If we turn the display off, this is going to stop displaying it here. But if we turn the collision guide on, it's going to show what the particles are actually colliding with. Okay, so there's multiple kinds of colliders. Like you can use a solver default and come into the bullet and look at what. So like turn off this visualization and look at what other kinds of colliders exist, like convex hull, concave. Concave is usually pretty accurate, but it's slow. Depending on what you want to do, there's different kinds of collisions. I'm gonna turn this off, and I'm gonna say I want a volume collision, because a volume collision we can use the mode volume sample. What's cool about volume sample is that you can create a VDV outside, which is this one, and use that as a proxy. So it's almost like it creates this volume and it collides with the volume, and it's just like much faster. And then this VDV voxel size is also referencing how detailed we want this VDV to be. So if we take this down to like 1, we're gonna get nicer collisions. Like if you guys look really closely at the piece that I made, I was like, damn it, I should have made more accurate collisions. Because if you look here, we can see that there is a little bit of a space in between them. Like if the collisions were more accurate, the liquid would be closer to the actual object. So this should be at 1, but I'm gonna keep it at 2, so because the less accurate the collision, the faster the simulation, right? So okay, so that's what this is doing, and this is referencing that outside. And the last tip that I'm gonna give you guys here is that you do not want to simulate with the collision guide visible. Makes your simulation really slow. So you just want to display your geometry here. And then last, I added a ground plane. Because if I don't add a ground plane, like think about it, like the liquid is gonna collide with the fruits, and then it's gonna go drill down, and then it's gonna go down like infinitely. So it's gonna start to like the clock, like tick 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 tick, meaning like your simulation is gonna get really slow, because the further away, like the more computation. Instead of like just put a ground and it hits the ground and just like it's gonna make it much faster. Okay, so let's go ahead and hit play. Oh, okay, hold on. You gotta touch on this too. So pop drag, what is it doing? It just like slows things down. And the viscosity. And then here's where the magic is actually happening, because if we play this with this off, we're just gonna keep a viscosity of 1 the entire simulation. So there isn't the viscosity is not gonna increase. It's always gonna be what it is. See, like nothing. Like you can increase it and make it like really viscous, but there's really not gonna be a change over time. And this is very low viscosity. It's just a 1 in viscosity. So what we want to do is come in viscosity, and I left you guys some sticky notes here so that you can see what's happening. So I'm grabbing the H, and the H is being fit. Fit the H. So like the H goes from number 1 to 450. We want the H to, we don't want to wait till 450 for the viscosity to reach a certain number. So we tell it H goes from 0 to 10, okay, and then we want to fit that between 0 and 1 so that we can control it on a round. So instead of going from 0 to 450, it's gonna reach the maximum. It's gonna reach 10 much faster. Therefore, the particles are going to increase in viscosity faster. Then I am adding this, which is a ramp parameter, and then the ramp parameter, instead of RGB color, I'm changing it to spline ramp. And then here is where we're grabbing the viscosity, and so like the viscosity is going from 0 to a 1 here. We want the viscosity value to increase much higher than 0 to 1. So the source min is 0, the source max, we know it's 1. The new source min and the new source max, I'm controlling them outside. So if you do like the middle click, you middle hit, click on promote parameter, you will see that you can now control them outside here. So you can now control them here. And you can see that my minimum value, I'm gonna set it to 1, and my maximum value, I'm gonna put it really high. 20,000 or something. So meaning like, once they are born, the viscosity is 1, and then this ramp controls how fast they reach this value. And then that value being the viscosity. So if we have 10 here, if we make it 5, this value is going to be reached. We're going to reach this value in half the amount of the time. So you can play with that to control the intensity of how fast the viscosity. If I push this up here, it's going to start very viscous, then turn unviscous, and then go viscous again. So let's see. Right now, it's going to start not very viscous, but then it's going to increase the viscosity as it reaches age of 10. So through until 10, it's going to be increasing the viscosity.